Physical computing is about building electronics that sense and respond to the world around us. And so oftentimes the response that we're after is some sort of movement. We want to open a valve or to flip a switch and or move a motor from one place to another. So this is the realm of electronic devices called actuators. Actuators are come in lots of shapes and sizes, but their purpose is always to introduce some sort of movement into the world. So this video is going to be primarily about this type of actuator. This is called a servo. And when the servo is driven by an appropriate signal, it's actually a pulse width modulated signal, the servo will rotate. And so this servo can only rotate 180 degrees, but it can rotate clockwise or counterclockwise. All right, so we're going to talk about the signal that is being sent to the servo to get it to rotate, and then we're going to look at a library that was written for Arduino that makes controlling a servo easy. All right, so let's get started. Okay, so hooking up the servo is very straightforward. The servo has 3 wires. This one has a red wire, orangish red wire, a yellow wire, and a brown wire. So the brown wire will get a connection to ground. The red wire will get a connection to the 5-volt power pin. Now servos use a lot of energy, they use a lot of power, and so you'll if you want to drive more than one servo, you'll probably have to have some sort of external power supply. But with this one servo, we can drive it directly using the 5-volt power pin on the Arduino board. And then the yellow wire gets connected to a pin, a digital pin. So here I'm connected to digital pin 9. All right, so that's how we hook up the servo. Yellow wire to digital input output, orangish red wire to 5 volts, brown wire to ground. All right. So the servo that we're using today, and actually most servos, are controlled by pulse width modulated signals. And these pulse width modulated signals have to be constructed in a very specific way. They have to have a period of 20 milliseconds, and then the on time is what determines where the servo will rotate to. All right, so let me set up a sketch here and demonstrate. Okay, so the first thing I'll do is I'll set up a variable of type byte to store the position, to store a value which will specify the position of the servo. So really what this is going to do is specify the on time of my pulse width modulated signal, how long every cycle the signal is high. So we'll initialize it with 0. Okay, so now I got my setup in my loop function, and in my setup function I'm going to I'm using digital pin 9 here, so I'll set the mode of that pin as an output. All right, and I won't use a variable to I'm only using pin 9, so I'll just directly put the 9 right in the function call there. So now I'm ready to construct my pulse width modulated signal, and I know that I need to have a period of 20 milliseconds. And let me back up here. I'm not going to use analog write for this because the analog write function, it generates a pulse width modulated signal, but it's not the right frequency. So I'm actually going to construct a pulse width modulated signal completely from scratch. I'm only going to use 2 different commands. I'm going to use digital writes and delays. All right, so let me get started here. So the first thing I'll do down here in the loop is I'll do a digital write on pin 9 to set it high, and then I'm going to delay for however long I specify in my position variable. And then I'll do a digital write on pin 9 low, and to get a full period of 20 milliseconds, I would need to wait here a time equal to 20 milliseconds minus however long I was high, however long my signal was high, which is position. Okay, so this isn't an exact way of doing this. It's not the best way of doing this, but I'm doing this for demonstration purposes. And I'll show you what the signal looks like on an oscilloscope. All right, so here is an example with the position variable set to 2 milliseconds. So you see the signal that's being generated on digital pin 9 here on the oscilloscope. The period, you can't see it down here, but the period is 20 milliseconds, and the frequency is then 50 hertz, and the duty cycle is 10%. The signal, during each cycle, the signal spends 2 milliseconds high and 20 minus 2, or 18 milliseconds low. And that corresponds to this position. So let me change this to 5 milliseconds and upload it and watch the servo move. And watch how the signal changes. Alright, so the servo moved. If I change it to 1 millisecond high and upload it, you'll see the servo move again. Okay, so again, just to summarize, the signal that is driving this servo is a pulse width modulated signal where the duty cycle corresponds to where you want the position of the servo to be located. So you can rotate the servo left and right by modulating the duty cycle of this 20 millisecond period signal. Okay, so the next thing I will do is I'll show you how to use a library that was written for Arduino to make all this very easy. All right, and we'll write a program that causes the servo to sweep left and right 180 degrees over and over again. All right, so this is the first time, I believe, that in the class we will be utilizing a library to boost the functionality of our Arduino. I got a blank sketch here ready to go. I got the setup function and the loop function set up, but there's nothing in them right now. Now, to use this servo library and to get all of its functionality into your sketch, you've got to import the library. Now, the library itself, all the code that constitutes this library as of today is part of the Arduino IDE, but I still need to import it into my sketch in order to get it to work. And the way you do this is you use a command called #include, and then you type the name of the library. So here it would be something like this: include, and then in angle brackets, capital servo.h, and then close the angle brackets. So this will import the servo library into my sketch and all the code that makes it up. All right, now the next thing I want to do is I want to create a servo object. So it's kind of like you're declaring a variable where the variable data type is servo instead of byte or int or anything like that. All right, so servo, I'll call it my servo, and so I've created a servo object. All right, so now I'm using digital pin 9. So what I want to do is I want to attach that digital pin to this object, like so. Okay, now it's ready to go. So now down in the loop, if I want to then set this servo at a specific position, this servo object has a method called write, and so this function will take a value, take an argument between 0 and 180, which specifies the position. The servo can rotate from 0 degrees to 180 degrees. So if I put a 0 in here, it'll initialize the servo in its sort of home position. All right, so let me compile this and upload it. And the servo is now at its home position. If I change the right to 180 and upload it, the servo will rotate 180 degrees. Uploading, uploading, uploading. So I had a little bit of a problem there. The servo draws a lot of power, and this particular servo is drawing so much power that it was interfering with the rest of the Arduino platform to function correctly. So I think I have that worked out. So let's upload 180, and you'll see it rotate 180 degrees. If I do my servo right 90, it'll come back to the 90-degree position. All right, so you get the idea. So we can use, so now I'm gonna pause the video. I'll write a sketch that sweeps the servo clockwise and counterclockwise 180 degrees and then back to 0 repeatedly. All right, so let me pause it, I'll set it up, and then we'll talk about it. Okay, so I got it all set up here. What I've done is I've written 2 for loops inside of the loop function. The first for loop is going to take a variable called POS for position. I know that means other things too. And it's going to take it from 0 to 180, incrementing by 1 every time through the for loop. And it's going to write this variable to the myServo object to set the position from 0 to 180 degrees. And it'll have a short 50 millisecond delay between these writes. Then the second for loop is just going to take it the other way. It's going to take this position variable from 180 degrees back to 0, incrementing by -1 every time through the for loop, and write that to my servo object. All right, so let me upload this, save, and upload. And we should see my servo sweep. All right, it's sweeping slowly. I'm going to change the delay to something shorter. How about 20 milliseconds? There you go. So now it's sweeping faster. It's going from 0 to 180 degrees, and then it's going from 180 back to 0. So I had a bug in my program, and the bug was that my position variable was of type byte. But in order for this servo object and the servo.write function to work correctly, it needs to be of type int instead. And I'm not entirely sure why, but let's go with it. So now you see it's the servo is smoothly sweeping back and forth from a 0-degree position to a 180-degree position and then back to 0. All right, so that's it for this lesson, and I'll see you next time.